The internet's very slow here.
This Hangout on Air is live.
We're doing it.
It's happening.
Hello, dearies. Welcome to Undersampled Radio, episode 48. It's a very special episode, as you can see, because we're wearing the same shirt.
Yeah, that's one reason.
And what?
We're in Paris.
We're in the same city.
We're both at the Subsurface Hackathon in Paris, France. And
it's awesome. And we have name badges. As you can see behind us, there's people hacking away on various projects.
We have something like 60 geoscientists and computer scientists here. We're at Total's offices at La Défense in Paris. They very kindly lent us their booster, which is a sort of, what is it? An entrepreneurship center.
Yeah,
for
it's
Total.
An innovation space. And though we don't have access to it, there's a VR lab and hardware hacking room down the hall, which is pretty cool. Maybe Matt will show that to you when he goes satellite in a few moments to interview some of the hackathon teams here. Are you working on a hackathon project, Matt?
No. Well, no. I always try and squeeze in a little bit of hacking. So we've been playing around with something one of the sponsors brought. Our sponsor from Amazon, AWS, brought an Echo. So we've been playing around with Alexa, sort of. Been a little bit underwhelmed so far, I must say.
A little underwhelmed.
So the goal there is to maybe write a couple of skills or something for Alexa. We'll see if anything comes of that. 50% chance, I'd say.
Also 50% chance that that's going to relate to our Undersampled Radio Segway activities, and I'm pretty excited about that.
Oh, right. Yeah, I'd forgotten about that. Yeah. That's going to be cool. I forgot about that link. Nice.
So what do you want to do next, man?
Well, I don't know. Do we want to talk about what's going on here, or just launch straight into it?
I mean, no, give it. Please give us.
Spiel.
Yeah.
So this is the 7th hackathon that we've run. We started, I think, in 2013 in Houston, something related to SEG, and now we're on the second one in Europe. This is easily the biggest. It's more than twice the size. It might even be sort of 3 times bigger than anything we've run before. Enabled by and sort of aided and abetted by the folks from Total. And it's the theme, I guess, is also kind of exciting this year. The theme is machine learning, which is obviously a hot topic that we mention a lot on the show, so it'll be familiar to most people. But it's
we should build a machine learning algorithm to generate conference rants. That would be like the ultimate
entire
podcasts thing
on any subject.
Yeah, it'd be better than our normal gig.
I feel like it's basically what we do.
SEG would be the seed word.
It would just.
I'm sorry, I interrupted you.
It would just generate exactly the same podcasts that we already generate, but with much more effort. So it's a perfect project for us.
Mm-hmm. Maybe much less cursing too.
Possibly less cursing. At least you'd have a slider for the amount of cursing you wanted.
I like it.
Per show.
Yeah.
So we started this morning with the hackathon part, but we had a bit of a sort of hors d'oeuvre yesterday. We have a cameraman today. Evan, can you just turn the camera around and introduce yourself?
Let's see you. Hi, Evan.
How do I look?
You actually, it is recording your voice too. You have a. Oh wait, shit.
No, he has this mic.
Wait, is that thing on mute? Yeah.
Yeah.
Okay, good. We're having, as usual, AV technical difficulties.
It seems even more complicated than usual, but so the teams all just started this morning. We had this is getting social media inception.
Pretty better.
The teams organized themselves essentially this morning with a little bit of provocation from us, and everyone was hacking, or not hacking, but the teams were sorted out by 10 o'clock, which I think is a record. It's what would you call that process? Organic, self-organizing mess.
If I had to describe it, it would use you'd have to slide up the curse word bar.
Right. It was, it's a hands-free biological process of finding not mating pairs in our case, but teams of 5.
Teams of 5 with remote participants as well.
It takes 5 parents to raise a hackathon project.
That's right.
So,
we ended up with a bunch of remote participants, which is this a first for a hackathon?
That is a first for our hackathons.
Didn't go smooth, but I think it's worked out, and people who couldn't make it over here in person are getting to participate. So it's a pretty cool thing.
It's awesome actually, because there's someone in South Africa, there's a guy in Peru, there's a couple people in the US. Mm-hmm. Where's the 5th one? Also in the US.
Also in the US.
Okay.
Houston maybe.
Denver, Houston, and I don't know who the 5th one is then. But anyway, those people all somehow have stayed awake all night, essentially, because they are multiple hours, like 7 or 8 hours behind, I think.
They started at 1 a.m.
Yeah, so that is, if there's a more committed person to hacking, I don't know who it is. Mm-hmm. That's hardcore. So kudos to those guys, Dan and Justin and Poway. Nice. So it's pretty exciting. Oh, I was going to mention the boot camp. Yes. Yesterday we had a kind of an entree in the form of a one-day workshop, like hands-on, a little bit of coaching in Python, like for beginners, a little bit of coaching in sort of scikit-learn for people who are new bit of Python but hadn't done machine learning before, and then I guess we had a team or a group doing deep learning for the first time and taking that through. So yeah, it was very diverse, just like today, very diverse mix of people. Am I on 1 or 2? No, it's okay. And that was also a really successful day. Like, people got new skills. We helped in most cases and didn't hinder too badly. And it was a fun day, full of energy.
It was my first chance to see a boot camp, and it was awesome to see light bulbs going off. I mean, really, really encouraging. So.
Yeah.
Well, let's go talk to some teams, man. Well, you go talk to some teams. I'll hang out here and relax.
You're gonna hang out and relax?
Yeah.
Okay. Well, so first we're gonna go find Lucas, but he's
right there.
Interrupt him too badly. Stay tuned.
Okay. So I'm staying here and waiting for Matt to turn his volume back on, which he has not done yet. So soliloquy time, as per usual. He's still talking. We have, I think, 3 or 4 or 5 teams behind me. You might be able to see from my camera if you couldn't see from Evan's recording earlier. I think Matt is trying to record right now. Anyway, check out those teams. There's a team back there working on the seismic GAN project. Matt, if you're recording, I can't hear you. Can't hear you.
No, can you say something?
Okay, can you hear us now?
There we go. Hey,
Nice.
Welcome to Undersampled Radio.
Sorry about the feedback.
That's okay.
That was pretty bad.
It's okay. The headphones. It felt good in the headphones.
Yeah.
So, what team do you have over there?
Okay, so what's the team called?
The Gangsters, yes.
Gangsters.
The Gangsters.
Yeah, pretty nice name. So this is Lucas, Steve, Jesper, and Walter. Yeah. So it's a bit of a dream team. And don't you have a remote participant?
Yes, we have Alfredo de la Fuente in Peru. Not online.
Right.
Yeah.
Okay. So the Peruvian robot is also a member of this team. So do you want to just describe what the project is in a nutshell?
Yeah, sure. So essentially what we're trying to do is model the seismic inversion process, but using generative adversarial networks. And essentially we're creating some synthetic data to train on. And then we want to go from a velocity model to seismic. but also be able to go from a seismic to a velocity model.
Okay.
And we're using something quite recent called a psychogan to do that.
A psychogan.
Psychogan.
Okay, a cyclegan. So what's the sort of architecture of a cyclegan? That starts to sound like some kind of iterative, self-reflecting GAN.
Essentially, it's two GANs that are, one takes an image and translates it into a certain domain, like into the seismic domain. So it takes a model, translates it into the seismic domain, and the other GAN takes a seismic image and turns it into a model. And then you've got two discriminators, which is part of the GAN, but the cycle comes from actually having to reproduce the input as you go through the two generators. You want to have the input correspond to the output in the end, but going through this intermediate step.
All right.
Yep.
Very cool. So, so Steve, have you guys got what are your kind of roles on the team, or are you all kind of pitching in the same stuff?
Well, Lucas is training the thing.
Yeah.
We've all been preparing test data a bit. I'm doing the front end for a web page so we can present the thing in a web app. Back end. It's Flash server and the actual script to run the forward pass on the train.
Okay.
Thing. I'm bringing it up on AWS.
Yeah.
Yeah.
Right.
So it's a bit of a ambitious thing.
Yeah. It
But
sounds
we'll at least
phenomenal.
have a G slide with the image of the output in.
Okay.
But hopefully we'll have a web app.
That's pretty cool.
Sure.
And how did you get this team? How did this team come together, Jesper?
I think it's Graham's fault, actually. I was talking to him like, yeah, I don't know, there's neural cell transfer that you did. It's pretty cool. I did it too. So I don't know. Posted it on Twitter. We got talking about it, and suddenly I got pulled into a conversation with, I think it was with Steve and Lucas in the beginning, and then an hour later, Wouter came in, and an hour later, Alfredo came in, and then we were settled.
Right.
So Graham did so much. But we got together a week ago, so we've been able to kick the training data.
Yeah. Right. So getting the training started. Yeah. And have you guys, I only just met you today really for the first time, but you took part in the SEG machine learning contest.
Yeah.
Like, have you been to a hackathon before? Have you been involved in a project like this before?
Actually. No, this is my first hackathon.
Okay. But is your background in kind of seismic stuff?
Yeah,
or?
seismic geophysics, but recently I've been turning to data science. So
okay.
It's been, recently took off some data science projects.
Right.
Learning from both. So this is awesome that there's sort of the combination of both in there.
Yeah, right. That's great. So, and where are you based?
London.
You're in London, okay, but you're Dutch, Belgian?
I'm Dutch, yeah.
Okay, awesome. So this is probably the most international team, I feel like, or one of them. So you've got a Dutch guy in the UK, a German in Denmark, a Brit in Spain, an Austrian in the UK, and a Peruvian in Peru. Okay. So at least one sort of non-displaced native somewhere. Okay, cool. Well, so that's the Gangsters.
That's the name, clearly. It's going to be pretty exciting to see what these guys produce. Over to you in the studio, Graham, while we say goodbye to these guys and go and find the next team to pick on.
You got it. Thanks for talking with us, guys. As they walk off, you may see the team Gangsters walk here back to their home behind me. There they are again. Give them a round of applause. Yes. Excellent. Yeah, no, that's a subject that Lucas and I have been talking about for a while. And then, as Jesper mentioned, we've been getting more and more people excited about it over the past week or two. Just it's an amazing idea. And in fact, we 2 episodes ago, Matt and I talked about it a bit. Looks like they're out in the field, as it were, drawing in more interviewees. Here we go. You're still on mute.
No, I like the countdown. That was a nice touch. Evan's actually going into the role of field production. Pretty nice. So okay, I'm here with Brendan Hall, Brendan is based in the US. And what's your team called? And what's it all about? Yeah, so a team called the Speak Section.
I will just play around with the AI a little bit.
If you could have a look at the sketch, because whatever.
It's different light photos. The pin section without a different cross polarization level. And we look at those pin sections and segment them and extract some features frequently and do some identifying them, shape of the porosity, what type of porosity might be, integrating porosity. And so where did this data come from? This doesn't sound like one of the data that you right, Simon. At the University of
and his group produces these images.
Yeah, right.
And do some analysis on that. So yeah, it's a great data set. I've previously done some work on conceptual image analysis, so we it was a good match in that sense.
Yeah, totally. And it's that because he was describing these data sets yesterday, and it sounds like each photo micropath is actually a 3D volume where the third dimension is polarization angle.
That's right.
Yeah, that's really, I've never seen a data set like that before, but
yeah, it's somewhat like a hyperspectral data set, like you might get from a satellite image, is that looking at light at different wavelengths.
Right.
This is like that, except you have different polarization angles.
Yeah, right.
So yeah, so it's a lot of features then to train machine learning algorithms with. So that's the fun part about working with this.
Yeah, and what kind of sort of machine learning models or patterns are you guys using?
Right now we're at the feature extraction stage.
Okay.
So what we're doing actually, these images are huge. It's a tiled image format. So there's a lot of little small images, but the entire image is maybe 80,000 pixels by 80,000 pixels.
Okay.
That's a lot of pixels if we're going to just look at the individual pixels themselves.
Yeah, it is.
So what we're doing is we actually are using a technique called superpixels to join up neighboring pixels into groups that are, it's determined are the same type. And that way we are sort of reducing the resolution in a sense. And then from those pixel regions, we'll extract some features.
Okay.
So we're going to look at textural features like heraldic features and local binary patterns to be able to, so if one of the middle grains looks like the other one in light, has the same sort of color, but a different textural pattern, it'll pick those up and be able to distinguish between the two.
Yeah, okay. I like that, that sort of simplification step. So that's based on a sort of local segments.
That's right.
Based on texture or based on color only?
It is, in this case, based on pixel features, so color in this sense.
Yeah.
Yeah.
Right. Okay.
That's right.
And you reduce the color depth as well? Like, are they like 24-bit color or?
They are RGB values.
Yeah.
Yeah. And so we're looking at that right now because we also need to stack these images up. We want to also make these superpixels based on all of those 10 polarizations.
Yeah.
So if you have, 3 RGB values, and then another 3 RGB values for the next angle, and then another, that's going to be a lot. So we're figuring out the best way to do that right now.
Yeah, okay, very cool. All right, well, I know you've got a lot of work to do, so we'll let you go back to your team and your hacking.
Yeah.
Good luck with it.
Thank you.
Yeah, well, maybe we'll try and do this again tomorrow and find out how things went.
All right, sounds good.
Cheers.
Thanks.
All right. That was the second team, so I'm going to hand back to you, Graham, while we go and find...
Okay, I've got it here over in the studio. I'm really enjoying this. We had a slight audio problem while we recorded even. Hey, there's the back of my head. Look at me. Hello. So yes, the other room would be good, guys. Good. Awesome. We've got several teams here working on well log information. I think that's where we're headed right now. I'm very interested to see where this project goes. I think they're reconstructing data, metadata from log headers. Nope, that's a different team. What is it? Go ahead.
You can go on
YouTube and watch them.
This team back here is logging in to watch now themselves live while we record.
We just want to hear the ideas of the other team.
Wait, I'm hearing some audio over there. What's happening in the field there, Matt?
Oh, we're on, we're live. Awesome. Okay, so I've come over here to another team, and it isn't a well-log team. Actually, this is another seismic team.
Team name, please.
So yeah, I'm talking to Claire Burney from. Actually, I don't know the name of your team.
It's not our fault.
It's not their fault. Our fault. Well, it's definitely not my fault, but
we'll see.
Yeah. So so what are you up to? And it's not your fault.
So what we're doing is we're taking the theory behind facial recognition, and we're trying to apply that to find faults in images. So we're doing a 2D image, and then trying to identify faults in there through using the Haar cascades method of facial recognition.
Okay, what's it called? The
Haar cascades.
Ah, okay. Haar cascades.
So I think that was the first technique for facial recognition.
Okay. It sounds like some sort of exotic Martian waterfall. Or
No, it's actually quite simple. It's almost just a case of black and white boxes. I like to think of it as filters. And it's quite easy to describe when you're thinking about a face. So you put these black and white boxes over and you're doing a subtraction between the colors. So if you had a box over your face and you have black over your eyes and there's white box in the middle, then there's going to be a big difference in, I'd say, the magnitude. So these parts are dark because your eyes are dark.
Okay.
And this part is bright because it's not sunk into your head.
Right.
And from that, they can actually train these cascades to find eyes.
Ah, right. Awesome.
Yes, we're trying to do that, but train it to find faults.
Okay. Yeah. So that explains why when I went in and visited their room before, one of them had OpenCV running on his laptop, and it was in real time finding faces basically in its field of view. So the plan is to sort of turn that same technology onto seismic to look for faults.
Yes, that OpenCV is great because actually they've already trained on their cascades.
Right.
And yeah, it's open source, and you can just take their XML files and run that yourself. As you say, we were running it off of the webcam.
Right.
But what you can also do from OpenCV is train your own cascades.
Right.
So we're going to give it a bunch of positive images, which are images that just contain a fault, and a bunch of negative images, so it could have traps or, I don't know, dipping layers, just flat interfaces. So that's your negatives and your positives. You put that in, and you train those cascades.
Right. So where are you going to get all these? Where are you going to get all these images from?
Synthetics.
Okay.
So actually, that's what we're working on this morning. We made loads of synthetics.
Generating little Earth models and forward modeling them, and to make some synthetic seismic.
Models.
Yeah, right. So how many kind of images does it take in each one of those sets?
From what I've read, the rule of thumb is at least 1,000 negatives and 2,000 positives.
Oh, okay.
So we're not talking like too small stuff.
Not too bad.
But yeah, it's not huge, and they're, I mean, pretty fast to make. You're talking 100 by 100 images, dimension-wise.
Okay. Yeah, that's not bad at all. And so then it'll be interesting to see how that sort of generalizes, because presumably your models are all fairly, like, they're all 100 by 100. They're all presumably fairly similar looking-ish because they come from the same types of models and so on.
Yeah, roughly. We've got faults changing in angles and different where your interfaces will be on them.
Yeah.
So you try to get quite a variety in there. But interesting to see if it works.
Yeah,
like, we're not 100% positive yet. But.
Right. No, I think this is one of the really interesting projects. I love the way you're kind of combining, well, synthetic training data, which I think is a nice concept because it's so much easier to get than labeled data, and then using kind of off-the-shelf tools like OpenCV and its Haar cascades to do the actual recognition. So very cool. We'll maybe try and check in with you guys again tomorrow, I think, and see how it goes.
Good.
Yeah. Good luck.
Thanks.
Thanks for talking to us. See you.
Awesome. So that's a really, really interesting project. Back to you, Graham.
Thank you. Thank you, Matt. Thank you, Remote Matt. We've been dealing with a lot of data types of issues over the past couple of days here. We've actually, if you're watching this episode and you're in need of data, please contact us because we're sort of collating data sets as we go along. As Matt mentioned, synthetic data is usually much easier to acquire than real data, and you can build it in the way that covers the input space as broadly as possible. Here's the back of my head again, which is very interesting. Are you back?
Yeah.
All right.
Back, baby.
Cool, man. Do this.
Yeah, it's pretty cool, eh? I mean, there's some really interesting projects out there, I think. Geology as well as geophysics.
Yes.
It's fun to see. I thought maybe it would just be kind of all seismic, and it's we got
I'm out of this.
seismic.
Wait, we got to get into this picture.
We got seismic. We got well logs. Yeah, right, because I'm thinking that one's us, but that's us.
Yeah.
Sorry. So yeah, we got seismic. We got well logs. We got thin sections, all sorts. So it's awesome.
Where do you need? What's happening?
So yeah, I don't know.
Our heads are really
are we going to be able to do another thing tomorrow? Do you think?
I hope so. Actually, I'd like to maybe do something with the demos, record them, broadcast them live. Is that acceptable?
That would be really cool.
I think it'd be the coolest thing ever.
But yeah, because we have a mic. We can stick that by the people, and we'll figure out a camera or 3 angles.
Yep.
Oh yeah,
We have tablets. Oh my goodness, we could have many camera angles. Be very cool. So,
all right.
Thanks for joining us here on Undersampled Radio. We'll see you tomorrow.
Hasta mañana.
Should I sign us off now?